Hi, I'm Matt Marshall, founder and CEO of VentureBeat, and I'm talking today with Brian McCarson, Vice President and Senior Principal Engineer of the Internet of Things Group at Intel. Hi, Brian. Thanks for joining us.
Hi, thanks for having me.
Brian, presumably we're talking about new computer vision applications on the edge. Can you tell us what you're seeing in 2020?
Well, what we're seeing is some interesting changes that are happening across a variety of different market segments. The one I work on currently is the industrial segment, so looking at how humans manufacture and distribute goods. And what we're finding is the advent of artificial intelligence technologies that can be applied from a vision-based perspective in the factory is really starting to take off. And the way these are being used is to try to help supplement some of the things that humans just can't really do naturally. And one of those most important applications is really around how you can detect manufacturing defects on products, whether that's looking for bad pixels on a computer screen for a laptop, a smartphone, a tablet, whether that's looking for manufacturing defects on critical components that go into an automobile that's being manufactured. The human eye is really good at detecting things like motion and color and changes in patterns. But when it comes to detecting nearly microscopic surface defects or fractions of a millimeter changes in size, this isn't really what our eyes are designed to do. But you can program a camera with a relatively simple AI-based application to be able to do some of those things that are really impossible to expect a human to do reliably. And so the whole field of quality control and defect monitoring in manufacturing is one of the most exciting new areas that I see really exploding in the industrial domain.
Brian, can you talk a little bit about maybe some customer examples? I don't know if you have any of some of these specifics around whether it's fixing pixels or observing the defects, and what are the things you can say publicly about some of your customer cases at Intel? Because I know Intel is driving some of this with your hardware and some of the software around what you're doing.
Absolutely. One of the first breakthroughs that we had in the industrial segment was when Intel was partnering with a cloud service provider named Alibaba that many of you know of. And we were working on trying to improve how factories can produce just-in-time production for a variety of different segments. And one of the factories that we started working with early on makes transmissions for a variety of different automotive makers. They're a metal fabrication company. They cast different types of metals, and aluminum is one of the things that they cast. And the aluminum casting process is extremely sensitive to even the smallest fluctuations in machine performance. And obviously, with the expectations that people have today when they purchase an automobile, they're expecting extremely high reliability. And so the automotive manufacturers themselves have very tight quality control requirements in what they will accept from their sub-suppliers. And who actually had some of the best quality control practices in the industry was still only able to detect about 1 in 5 of the manufacturing defects that they had in their line with a human eye inspection. It wasn't that they didn't have enough people there to inspect or that they didn't have workers that were really dedicated to what they were doing. They were asking humans to detect things that the human eye isn't really designed to detect. And when we were able to work with them to understand what they wanted to extract in terms of information they were trying to gather on the products as they were being manufactured, we were able to help them come up with a very scalable way of detecting defects immediately after these products were produced. And we were able to move their defect detection capability from 1 in 5, or roughly 20% positive defect detection rate, to greater than 99% defect detection rate. And the cost per machine, this company spends well over $1 million per tool. The cost per machine to deploy the hardware and the software required was a few $1,000s. So for literally a return on investment that's measured in days, they were able to go deploy what turned out to be one of the world's most advanced defect quality control implementations that could be implemented right directly on the factory floor without any machine retrograding. And this was pretty exciting for us. At first, we were thinking, wow, did we just get really lucky that we just happened to find that one problem that was relatively easy for us to go help solve? But what we found out as we started working with hundreds of additional factories globally, that we're all swimming in opportunities like this. And now that AI is becoming more accessible, more affordable, and some of the enabling software tools that Intel is providing makes it simple for you to go deploy an AI-based solution on a PC right next to an existing machine on the factory floor, simple relative to what it was even 2 years ago. This is really creating, I think, a fantastic opportunity for factories to improve their operating margins, for factories to improve their operating margins by improving product yield, reducing the number of customer returns, and ultimately have a very significant environmental impact. Because a large portion of the Earth's greenhouse gas emissions come from the manufacturing sector. And if you can improve the efficiency of that sector, even by a few percent by improving yields, that can have a massive impact on overall global greenhouse gas emissions. So there's a lot of things that have come together to make this really a great opportunity in the market for companies who want to capitalize on these now available AI innovations that are in the market and really see how they could turn those into profitable businesses.
Brian, you talk about the accessibility and a number of factors that have come together recently that weren't here before. For decision makers that are listening to you, can you maybe pick out one or two of the top trends that you see that are existing now to make it suddenly accessible in 2020 versus say a year or two ago? Right, you talked about declining price in the hardware, right, and maybe the software accessibility and UI. There's the algorithms, presumably CNN-driven, right, convoluted neural networks and deep learning and computer vision that's presumably been around, but improving rapidly. Are they all coming together in like a Cambrian explosion? It's at a single time, or are there one or two things that listeners here should actually keep an eye on in terms of making it relevant for them right away this year?
Well, there's a few things that I think have come together in the market in a really positive way in recent years. One is there's more open source software capabilities that are now available in the market to help make it easier for people to tap into the value of the transistors that they purchase in a processor with a either integrated GPU or a discrete chip that they would add on top of existing hardware. Whereas before, it really took a specialist to go in and try to unlock all that goodness that comes with the silicon that you purchase. So that's one. Certainly at Intel, we've, of course, taken this open computer vision community that Intel has supported for many years and started translating that into a toolkit known as OpenVINO for visual inferencing capabilities at the edge, and have been populating that with a number of models or algorithms that are ready to go to get people started right away, so that you don't have to be an expert in the field with 10 years of AI experience to be able to go in and start making progress. And the way the software development community often works is they will smartly go and look and see what kind of code is already available from people who have solved these problems before, and use that as the starting point and then make improvements to specialize that code for exactly what they're trying to do. And we can contribute to that more openly now, both at Intel, but more broadly in the overall AI ecosystem. So I think those are some interesting factors. The open source community, the availability of additional tools, and making it easier to unlock the value of hardware have all come together at a really good time. Additionally, there's been several other markets that have been happening, market evolutions that have been happening over the previous years around computer vision. And that's resulted in some basic algorithmic capabilities around feature detection, object detection that just didn't even exist a few years back. So now taking some of those existing tools and capabilities, adapting them to a different use case can really get you started with an 80-90% effective solution. So you're only having to do some minor tweaking along the way to get up to 96, 97, 98% plus performance.
Brian, we talked a lot about the technology side. If we take a look at the corporate transformation side, right, where a lot of companies have moved to embrace the cloud, and you talked about not necessarily focusing, stopping at the data center, but actually taking things down to the edge. Can you talk a little bit about what that means for transformation inside the end user of some of these technologies? What are some of the challenges you're seeing in 2020?
Yeah, one of the biggest challenges that we have is a lot of edge software is hard-coded, proprietary, or locked or tied to one specific set of hardware. What we're finding is the world is getting tired of that. The world wants to have more cloud-like experiences at the edge. We've gotten used to the fact that, we've moved away from having a BlackBerry-style device that you purchase that comes preloaded with all the software you're ever going to have, and you just configure it to your profile to do an email push and pull, to having a smartphone type device where you're buying excess compute, connectivity, and storage, but because it's a microservices-based architecture, you're able to customize it for your needs, and you can add and remove apps at will without having to program that device manually. People are wanting to see that cloud-like experience extend down to the edge. And so as businesses and companies are making decisions about what's most important to them and what technologies do they want to go deploy to help solve some of their business challenges, I would ask everyone to pause and think about how future ready is the approach that I'm thinking about taking at solving this problem. Have I selected a set of technologies that are going to create a foundation that I can innovate on afterwards? Or am I locking myself into another proprietary walled garden? Am I trying to extend that cloud-like capability closer to the edge? Or am I locking myself into code that is going to take an expert to try to be able to unwind if I ever need to make an upgrade or an enhancement? And so looking for that microservices architecture with virtualized or containerized compute modules, and trying to focus on the value-added applications that you can deploy on top of that, I think is really key to making your factory, your retail store, your smart cities, your automobile more future ready. And that's going to facilitate a much more adaptable, agile deployment of AI in the future.
Brian, let's talk a little bit more about the challenges organizations are having to unlock some of this value. I think in the abstract for this conversation that we came up with online, we refer to analytics pipeline and companies needing that and to work in tandem with AI algorithms. Is there anything more you can talk about for that decision maker who may be listening to this in terms of the challenges organizations have?
So yeah, the challenges that people face are not always obvious, but they're definitely real. Talking about deploying a microservices architecture at the edge sounds fantastic, but there's a reality that machines have been existing for decades that use proprietary code. And take the industrial segment as an example. There's one company that Intel works with who has documented all the different languages, different programming languages and communication protocols that the machines on their factory floor speak, and they counted over 200. So it's like trying to conduct an orchestra in a factory with 200 different instruments all on their different sheet music, all communicating completely differently. If you can't get everyone aligned, it's going to be extremely difficult to try to automate things. And so as companies are thinking about the decisions that are needed in order to decide what technologies go into their factory floor, go into their retail store, go into their smart cities deployment, they should be thinking about how scalable is this? And are there open source technologies that I could be using that will help abstract away some of that proprietary information lock that people have been dealing with for decades with some of these legacy systems that exist? And for machine builders, for companies that are thinking about getting into business, they should be thinking about how do they concentrate on their value added components at the application layer and not contribute to this proprietary walled garden approach by adding in yet another language or communication protocol. Because just like we've seen alignment in the cloud domain and in the network domain, we're going to see that convergence in the edge domain. I don't think it's going to happen in my lifetime that there's going to be like one universal communication protocol, but there's going to be microservices architectures that allow you to abstract away some of that communication specific challenges and really normalize to a standardized way of communicating between devices and applications.
Great. Hey, Brian, we got another minute left. In terms of just putting a size to this market, I'm wondering if you've actually looked at that, right? If a lot of us are familiar with the conversational AI application area, which is something I think everyone can relate to, right? There's every company is going to need a way to communicate with some sort of virtual agent with their customers. With computer vision, sometimes you start wondering, okay, how big is that market where you actually need to be able to, where you're in a factory, you're an industrial supplier, for example, perhaps. But as you took a look around, how big is this market? Have you tried to put a size to it?
Well, we have, and what we find is pretty astounding. Let's just take the industrial segment alone. So these are the factories that make all the products that we consume, whether it's furniture or phones or laundry detergent. All these factories that are building the goods that we consume. The industrial automation business, just the industrial automation portion of that, is a $500 billion a year business globally. And more of those companies are pushing their industrial automation systems to be AI based. And more of those are finding value in utilizing vision based AI capabilities to help them go solve challenges that they weren't able to solve before with just traditional time series data analytics. So it's not that time series data analytics is going away. That market is continuing to grow. But what we're seeing is right on the heels of that, the vision market is following as well. And I think it's creating a multiplier effect in the AI market right now, where this $500 billion a year industrial automation market is really over the next 2 to 5 years is going to see a very massive shift towards both a harmony of time series and vision-based AI applications, whether it's improving machine uptime, reducing factory defects, doing a better job at tracking inventory and storing that inventory. AI is really able to solve a lot of challenges today that weren't really economically or technologically feasible even just a few years ago.
Ryan, I see we're out of time. Thank you very much for joining us. It's fascinating.
Thank you for having me. It was my pleasure.